وعليكم السلام.
Today we'll start the last topic of chemistry, which is stoichiometry. In this chapter, we'll learn about the modes, empirical formula, and molecular formula. These are the things mainly. This is related to the calculation. In this chapter, most of the topics are related to calculation. First, we start with empirical formula. The term empirical formula, the formula which represent the simplest ratio between the atoms present in a compound. So when we work out the simplest ratio between the atoms present in a compound, that formula is refers to empirical formula. And example, if the formula of the compound is having a actual formula of C5 and H10. So what will be its empirical formula? The empirical formula, when we take a simplest ratio between 5 and 10, so the empirical formula will be 1 is to 2 the ratio. So that will be equal to CH2. Same way, if a compound is having a formula, actual formula C3, H6 and O3. When we take a simplest ratio of carbon, hydrogen and oxygen, so it will be CH2O. But some of the compounds, they have the same molecular and empirical formulas. Like if it is written C2 and H5, so for this compound we cannot further simplify. 2 and 5 is already in a simple ratio, so this time it will have the same empirical formula. So the formula which represent the simplest ratio between the atoms present in the structure, we call that as empirical formula. But how we can find empirical formula? One way is from a molecular formula, we can just take a simplest ratio. But there is also another method. Sometimes if the percentage or the masses are given, so if the percentage or the masses are given, then what we will do? We have to follow 3 steps. Number 1, divide by atomic mass. That is the first step. Number 2, divide by smallest value. And third one, either round off or multiply to make whole number. So these are the 3 steps which we will follow to find the empirical formula if percentages or the masses of elements are given. Example, if I say a compound contains 82% carbon and 18% hydrogen, find its empirical formula. So we have a compound which contain 82% carbon and 18% hydrogen, and we have to find the empirical formula. So we have carbon, we have hydrogen, 82% carbon is there, and 18% hydrogen is there. Now, what is the first step? Step 1 is divide by atomic mass. So when I take the atomic mass using a periodic table, carbon will be 12. So 82 divided by 12. What's the answer for this? 82 by 12. 82 divided by 12. 6.83. Whenever you're taking for empirical or calculating empirical formula, take 3 decimal places. So 6.833. And hydrogen atomic mass is 1, so 18 divided by 1, so we'll get 18 again. So that is step 1, that divide by atomic mass. What is step 2? Step 2 is divide by the smallest value in the combination. Which one is the smaller value, 6.833 or 18? So the smaller value is 6.833. So we'll divide both of them by 6.833. When you divide 6.833 by 6.833, this will be 1. And 18 divided by 6.833, that will come out 2.63. Or if you take the first value, like example, if I take 18.5, the first value, and this one is 17.5. The same procedure we will follow. So 82 divided by 12, 82.5 divided by 12, and 17.5 divided by 1. Why divided by 12? Because the first divide by atomic mass. So this will be 6.875, and this is remaining 17.5. So step 2 is divide by the smallest value. The smallest value is 6.875. 6.875. When we divide by the smallest value, so this will be 1 and this will be 2.54. Now, whenever, because now what are the values you have? One of the value is 1, another value is 2.54. So what we want it to be whole number. So how this can be a whole number? Because 2.5 I cannot round off to 3, or 2.5 I cannot just round off to 2. So what we will do, whenever 1.5, 2.5, 3.5 is there, what we will do, we'll multiply the numbers by 2. So when we multiply both numbers by 2, this will be 2 and this will be 5. Whenever any value is like 1.5, one of the values 1.5, 2.5, 3.5, 4.5, 5.5. Whenever 0.5 is there, what you will do? You will multiply both numbers by 2, because you want the ratio to be 1 is to 2.5, but you want the numbers to be in whole number. like these final numbers should be in a whole number. That is why we are multiplying both by 2. So how many carbon atoms are there? It contains 2 carbon atoms. And how many hydrogen atoms are there according to empirical formula? So empirical formula of this compound is C2H5. Whenever one of the values 1.5, 2.5, 3.5, you'll multiply them by 2. Is it clear? Another example, these atomic masses you can work out, you can find from the periodic table, because this is a paper 4 question, so you will have periodic table with you. You can just use the periodic table to find the mass. Another example, find empirical formula of compound. Contain 75% carbon and 25% hydrogen. So the steps which we will follow, the step 1 is divide by atomic mass. Step 2 is divide by the smallest value. And step 3 is either you will round off or multiply to make a whole number. So in this question we have carbon and hydrogen as well. 75% carbon and 25% hydrogen. What is the first step? First step is divide by atomic mass. So you will use a periodic table. Carbon atomic number is 12 and hydrogen atomic number is 1. So 75 divided by 12, that's 6.25. So this will be 25. That is, step 1 is done. Step 2, divide by the smallest value. Which one is the smallest value in the combination? So we'll divide by the smallest value, 6.25 and 6.25. 6.25 divided by 6.25, that is equals to 1. And 25 divided by 6.25, what's the answer? 4. So what is the empirical formula of this compound? It contains 1 carbon and it contains 4 hydrogen. So CH4. That is the empirical formula. Is it clear? This example. Okay. Now some practice questions related to empirical. Answer is given. First thing, because we discussed now the empirical formula, so we'll do first empirical formula and then how to get the molecular formula. That's the second part. So in this question, determine the empirical formula of a compound with the following composition: 48% carbon, 4% hydrogen, and 48% oxygen. Answer is given, but you don't have to copy the answer. You have to show how you will get this answer. Now the first one, carbon is there, hydrogen is there, and oxygen is there. Carbon is 48%, hydrogen is only 4%, and oxygen is also 48. The step one is divide by atomic mass. So carbon atom, when you check the periodic table, carbon is 12, so it will be 0.33. For which, sorry, 48 divided by 12. So 48 divided by 12, that is 4. For hydrogen, atomic mass is 1, so 4 divided by 1, that is 1. And oxygen is 48 divided by 16. So 48 divided by 16, that will be 3. 4 divided by 1, that's also 4. Now what we have to do, the step 2 is divide by the smallest value in the combination. When we divide by smallest value is 3. So 4 divided by 3, what will be the answer? 4 by 3. So 1.333. Recurring decimal is there. 1.333. This also 1.333, and this will be 1. Now again, if one of the value is 1.3333, what you will do, you will multiply all of them by 3 to make a whole number. Rounding off is only done when it is closer to the whole number. 1.33, you will not consider that as 1, because if you consider all of them as 1, the simplest ratio will change. So at the last, I will mention what is the last number. So according to that, so what we will do in this case, if it is 1.33, what you will do, you will multiply all of them by 3. Because if I multiply by 2, look, if 1.33 I multiply by 2, what it will make? It will make 2.66. So, but that's not a near to whole number. But if I multiply 1.33 with 3, that will be equal to 3.99. So that is 3.99 is approximately equal to 4. So we have to multiply with that number, which will make a complete whole number or closer to the whole number. So 1.33 multiplied by 3, that's equal to 4. 1.33 multiplied by 3, that's equal to 4. And the oxygen will be 3. That's why the empirical formula of this compound is C4. We are multiplying all of them by 3. 1.33 multiplied by 3, that's equal to 4. 1.33 multiplied by 3, that's also equal to 4. And this was a 1 multiplied by 3, that's equal to 3. So the empirical formula is C4, H4 and O3. Is it clear? When we have to round off or multiply, we have to multiply all of them. So if it is 1.33, always keep in mind you have to multiply all of them by 3 so that it will make a whole number. Another example, the question is determine the empirical formula of a compound with the following composition. It contains 36% carbon, 4% hydrogen, 28% nitrogen, and 32% oxygen. So when we write, carbon is there, which is 36%, hydrogen is there, that is 4, Oxygen is there, that is 28. Sorry, nitrogen is there, that is 28. And oxygen is there, that is 32. So step 1 is divide by atomic mass. So carbon is 12, so 36 divided by 12, that is 3. Hydrogen is 1, 4 divided by 1, that is equals to 4. Nitrogen atomic number is 14, 28 divided by 14, that's equal to 2. And 32, oxygen is 16, so 32 divided by 16, that's equal to 2. That is step 1. What is step 2? Step 2 is divide by the smallest value. So when we divide by the smallest value, this will be 1.5, this will be 2, this will be 1, this is also 1. Now you can see one of the value is 1.5. So one of the value is 1.5. So what I have to do is 1.5, 2.5, 3.5. I'll multiply all of them by 2. So when I multiply all of them by 2, this will be 3, this will be 4, this will be 2, and this is also 2. So the final answer is it contains 3 carbon, it contains 4 hydrogen, it contains 2 nitrogen, and it contains 2 oxygen. So C3H4N2O2. One more example of finding empirical formula. A compound contains carbon, hydrogen, fluorine, and phosphorus. Carbon is 24, hydrogen is 7, fluorine is 38, and phosphorus 31. The first is divide by atomic mass. Carbon is 12, so 24 divided by 12, that's 2. Hydrogen is 1, so it will be 7. Fluorine 38. Fluorine is, when you check the periodic table, it is 19, so it will be 2. And phosphorus is 31, so that will be 1. Then step 2 is divide by smallest value. Which one is the smallest value? That is 1 is the smallest value, so I will divide all of them by 1. But when I divide all of them by 1, it will not make difference to the final answer. So this will be 2, 7, 2, and 1. So what is the empirical formula of this compound? It is C2H7F2 and P, the phosphorus. Is it clear? So this is how we find the empirical formula of a compound. After the session, I will share this worksheet with you so you can also practice the rest of the questions. The second part is finding the molecular formula. From empirical formula. So how we can find the molecular formula from empirical formula? Actually, the molecular formula is empirical formula multiplied by n. What is the meaning of this n? This n is equals to molecular mass divided by empirical mass. So if we want a molecular formula, the molecular formula is empirical formula multiplied by n. And what is n? N is molecular mass divided by empirical mass. So example, empirical formula of the compound CH4 or C2H5. Find its molecular formula if molecular mass is 58. So that's a question. The question is find empirical formula of the compound is C2H5. Find its molecular formula if molecular mass is 58. Now first thing, to get the molecular formula, the molecular formula is empirical formula multiplied by n. So molecular formula is equals to empirical formula, which is C2H5, and that is multiplied by n. But what about n? How to get this n? What is n here? N is molecular mass over empirical mass. So n is equals to molecular mass. The molecular mass is given in the question 58. What about empirical mass? How to get the empirical mass? Empirical mass you can get from empirical formula. Like here you can see empirical formula C2H5. So empirical mass will be carbon is 12 multiplied by 2. Why 12 multiplied by 2? Because 2 carbon atoms are there. That's why it is multiplied by 2. Plus hydrogen is 1 multiplied by 5. So 12 multiplied by 2, 24 plus 5. So 24 plus 5, that is equals to 29. So 29 is the empirical mass. So molecular mass is 58, empirical mass is 29. So 58 divided by 29, what we will get? We will get 2. So value of n here in this question, the value of n is 2. So in place of n, I will write 2 here. So C2H5 multiplied by 2. So when it is multiplied by 2, it will become C4 and H10. So molecular formula of this compound is C4H10. So I'll repeat again. To get the molecular formula, it's empirical formula multiplied by n. Empirical formula in the question is given C2H5, and what is n? N is molecular mass divided by empirical mass. Molecular mass is given in the question, which is 58. Empirical mass we don't know, we have to find. So how will we find empirical mass? We can find from empirical formula, which is C2H5. So 2 carbon multiplied by 12 plus hydrogen is 1 multiplied by 5. So total is 29. So 58 divided by 29, the value of n is equals to 2. It will become C4 in H10. Is it clear? Another example, the molecular formula is equals to empirical formula multiplied by n. Empirical formula in this question, this example is C2H5. So that's why we write C2H5. And multiplied by n, what is n? N is the molecular mass divided by empirical mass. The molecular mass is given 58, so that is 58. And what is empirical mass? Empirical mass is from empirical formula. That's why 12 multiplied by 2 plus hydrogen is 1 into 5, which is 29. So empirical mass is 29. When you divide them, you will get n is equals to 2. So empirical formula multiplied by n. So C2H5 multiplied by n, which is 2 here. So it will become C4H10. I'll give another example. Say empirical formula of compound is CH2. Find its molecular formula when molecular mass is 42. So empirical formula for compound is CH2. Find the molecular formula when the molecular mass is CH2. So the formula to calculate to find the molecular formula from empirical formula, that is molecular formula is empirical formula multiplied by n. So molecular formula is equals to empirical formula multiplied by n, but we don't know what is the value of n. How to get the value of n? N is molecular mass, which is 42, divide by empirical mass. Empirical mass, carbon is 12 plus hydrogen is 2, so 12 plus 2, 14. So 42 divided by 14, what we'll get? We'll get 3. So it means the value of n is 3. So in place of n, what we will write? We'll write 3. So this 3 is multiplied with carbon, this 3 is multiplied with hydrogen. So this will become C3 and 2 multiplied by 3, 6. So C3, H6 is the molecular formula. Is it clear, this example? From where I get 14, it's empirical mass. Empirical mass, it's from empirical formula. Carbon is 12 plus hydrogen is 1 multiplied by 2. Because the value of n is a molecular mass divided by empirical mass. So in the next question, question 6, determine the empirical formula of the following compositions: 60% carbon, 12% hydrogen, 28% nitrogen. So the empirical formula will be C5H12 and N2, and if this compound has a molecular mass of 300, what is the molecular formula? So first what we have to do, we have to first find empirical formula. So how we can find the empirical formula? Divide by atomic mass, then divide by smallest value, and then round off. So carbon is there, hydrogen is there, and nitrogen is there. So carbon is 60% carbon is there. This compound contains 60% carbon, 12% hydrogen, and 28% nitrogen. 60 divided by 12 atomic mass, hydrogen 12 divided by 1, nitrogen 28 divided by 14. So this will be 5, this will be 12, and this will be 2. Then we divide by the smallest value to divide, so that is 2, 2, and 2. So this will become 2.5, this will become 6, this will become 1. Whenever one of the values 1.5, 2.5, or 3.5, what we'll do, we'll multiply all of them by 2. So when we multiply all of them by 2, it will become C2, H12, and N2. That is the empirical formula. But in the question, we need empirical formula, and after getting empirical formula, we need molecular formula. So how to get a molecular formula? The molecular formula is equals to empirical formula multiplied by n. And the empirical formula already we calculated in the previous part. Sorry, this is 5 is there, not 2. So this is C5, H12, N2 multiplied by n. Now how to get the value of the n? N is equals to molecular mass divided by empirical mass. Molecular mass is given 300. What about empirical mass? How to get empirical mass? Empirical mass from empirical formula. So carbon is 12 multiplied by 5 plus hydrogen is 1 multiplied by 12 plus nitrogen is 14 multiplied by 2. So 60 plus 28 plus 12, that will make 100. So empirical mass is 100. So the N is 3. So if N is 3, you have C5, H12, N2, and that is multiplied by 3. So it will become C15, H36, and N6. So that is a molecular formula. Is it clear to everyone how to calculate the molecular formula? So I'll share this worksheet with you related to empirical and molecular formula.